My friend got asked this question above when he was doing a quant interview in New York City. I'm going to talk about two different solutions, but I want to focus this video on why are people asking these questions? This problem is featured in lots of real analysis textbooks. I assign it to my students every year on homework. I think once I put it on a final exam. It's not too bad if you know what a derivative is and if you spent the whole semester writing these sorts of proofs. Pause the video here to take a look at that proof. This is what I would expect a mathematician might write. Does that mean to get a job you have to grind through random problems from textbooks? No, not at all. And actually I want to show you a proof here that doesn't use any calculus, that just shows thinking. By the way, I'm a math professor. I don't have any experience working in industry, so I don't actually know what they're looking for. If you work in these industries, let me know. But here are my thoughts. In a technical job, you're going to have lots of technical details that you have to really understand what's going on. And in this problem, and maybe the interviewers would give you a hint, where you take the difference of two things and take the absolute value, that's just the distance between those things on the number line. And so in other words, what's happening here, and I may as well put absolute value over there, it's going to be the same. This is saying that the distance between the outputs of a function is less than or equal to the square of the distance between the inputs. So if two inputs were 5 apart, their outputs would be less than or equal to 25 apart. Given this technical condition, and then when we plug in 0, we get 8. And the question is, what if we plug in 1? Well, let's just see what happens, right? F of 1 minus f of 0, according to this formula, it's got to be less than or equal to 1. In other words, whatever this output is, it has to be a distance less than or equal to 1 from the number 8. That's enough that we know already that f of 1 is between 7 and 9. Now is where the big insight comes. When we square a number, if that number is bigger than 1, it's going to get larger. But if we square a number that's between 0 and 1, that square is actually going to be smaller, sometimes a lot smaller. So what happens if instead of going straight to 1, we first figure out what happens, say, at 1/2? And if we go from 0 to 1/2, well, now that says f of 1/2 is going to be at most a distance of 1/4 from 8. And that tells us that f of 1/2 is between 775 and 825. Now we ultimately needed to find f of 1, so we have to keep going. But if we do a similar thing comparing f of 1 and f of 1/2, we can narrow down that f of 1 now is between 7.5 and 8.5, which is a lot better than just being between 7 and 9. Now I think we have a clear idea of how to continue, and the question is, can we technically do it or at least explain what the idea would be? For instance, here, if we did 100 steps starting with 0.01, then we would get this bound here. We clearly see what's going on. I think something like this is pretty convincing, and maybe this is where the interview would stop. If you're a mathematician or a math student, you might want to write out a more formal proof saying that instead of doing 100 steps or 1,000,000 steps, what if we did n steps? And we could write out something like this, working through things using absolute value, using something called the triangle inequality, and we could show that f of 0 and f of 1 are going to be arbitrarily close, within 1 over any number that we decided. And so at the end of the day, we would be able to show that that number f of 1 has to be the same as f of 0, which is